Today's video is about finding the roots of quadratic equation. Quadratic equation. Nature of roots of quadratic equation. Equation. Roots mean when you solve any equation, it may be linear, quadratic, or cubic. The answers you get, they are called roots of equation. And nature of root means you have to identify what is meant by nature of root. It means that when you solve a quadratic equation, sometimes you get two real and distinct root. Sometimes you get non-real roots. And thirdly, roots may be real and equal. So these three things describe the nature of the roots of a given equation. So without solving a quadratic equation, you can find the nature of root. So I give you examples that how can you find nature of roots without solving it. For example, you are given an equation of the type quadratic equation x square. Question is find the roots of the given equation x square minus 5x plus 6 is 0. So you can apply quadratic formula, which is x equals to minus b plus minus b square minus 4ac over 2a. So you apply this formula. Minus 4a, substitute values, and 2 into value of a is 1. So when you solve it, your answer is 25 minus 24 over 2. So 25 minus 24 is 1, and square root of 21 is also 1. So we have now two roots. So 25 minus 24 is 1, and square root of 1 is 1. So you can write 5 plus 1 by 2, one of the value, and the other value is 5 minus 1 by 2. So 6 by 2 is 3, and 4 by 2 is 2. Now these two values are called roots of equation. And when you observe, then you see that these are real and unequal, or real and distinct. But without doing all this method, without applying this whole way, we have another way of writing, finding the nature of this root by using this expression, which is inside this square root, b square minus 4ac. This is called discriminant of the equation. This is called the discriminant, simple discriminant. So I must write here, and you will see without applying this quadratic formula, you can just find the discriminant. Discriminant is b square minus 4ac. And you substitute values here. Let me write full spelling of discriminant. So value of b is minus 5, minus 4a is 1, and c is 6. So when you solve it, your answer is 25 minus 24, which is 1. And 1 is a positive value. So whenever you get the value of discriminant is positive, then it indicates that the equation has two distinct roots. Two distinct roots. So this is how you can find the nature without solving it. So this is called two distinct roots. When b square minus 4ac is greater than 0, then equation has two distinct and real roots without doing all this. And similarly, when you find the value of uh, b square minus 4ac and you get a negative answer. Obviously, here in this equation, in this formula, you are unable to solve the negative numbers inside a root. So whenever you get a negative value of this b square minus 4ac, which is means less than 0, then your answer is that roots are not real or zero root. So I showed you examples. For example, question is of the type x square plus 2x plus 3 is 0. When you find it discriminant, the expression inside the root in quadratic formula is called discriminant, which is b square minus 4ac. And you substitute value here. This is 4 minus 12 is minus 8, and this is less than 0. So whenever you get a negative value or a negative number, then it shows that equation has no real roots, because you are unable to solve negative number inside root. So the second condition for identification of nature of root is if b square minus 4ac is less than 0. And third, for example, you are given an equation of the type x square minus 6x plus 9 is 0. So when you solve this equation by applying quadratic formula, you write here minus b plus minus b square minus 4ac divided by 2a. This is plus 6, and here 36 minus 36, which is 0. So if you write 6 plus 0 by 2, your answer is 3. And when you solve 6 minus 0 by 2, again, your answer is 3. So you observe that you are getting real and equal roots. And it happens only when the expression inside this root sign is 0. So we conclude that for example, when you solve it by using formula b square minus 4ac and find the value of this discriminant b, which is minus 6, substituting the value of b, which is minus 6, and a1 and 9 is c. So we substitute values here. Minus 6 square, minus 4, 1, and 9. And when you solve it, your answer is 0. So we conclude that whenever this expression discriminant b square minus 4ac is 0, then roots are real and equal. So you have to memorize these three conditions. B square minus 4ac is greater than 0. It means roots are equal and distinct. Secondly, when b square minus 4ac is less than 0, then roots are non-real, or at times we write no roots. Or b square minus 4ac is 0. It shows that roots are real and equal. So this is real and distinct, not equal and distinct. So you have to memorize these three conditions: real and equal, real and distinct, and no non-real roots. So memorize these three conditions to solve the question. And we solve a few questions from your exercise now. For example, I'll take some word problems. For example, question is, find the values of k find the values of k for which three x square minus 4x plus 5 minus k is 0. So you see, this is the quadratic equation. And condition given to you is values of k for which this equation, which is quadratic, has two distinct roots. To solve this condition, first you need to identify the condition of the, you can apply, that is, in this case, it is two distinct roots. So highlight this condition, that roots are distinct. And now memorize the condition. Okay, what should we do now? Because the roots are distinct, so it means that discriminant is greater than 0. So here you will apply the first condition. You will write b square minus 4ac is greater than 0. Now we place value. B is 3, b is 4, a is 3, and c is this whole constant 5 minus k. Because we are solving an inequality, so you will get range of values of x. K is greater than 0. And when you solve 60 and 16, your answer is 44. Plus 12k is greater than 0. Now you can take this 44 on the other side. So you can write here 12k is greater than minus 44. So k is greater than minus 44. This is minus 44, and when you take it, it will be positive here. Now you can simplify 3 by 11 by 3. And when you solve, so answer is k is greater than 3 whole 2 by 3. So this is how you can find the same process. You can repeat. If here it was written, okay, find the values of k for which the roots are equal, then you apply condition b square minus 4ac is equal to 0. It depends on this highlighted part. And if it is here, okay, the roots are non-real, then you will write here b square minus 4ac is lesser than 0. And then we solve to find the value of k. Similarly, we can apply same condition when you are solving questions in which you are given intersection of a line and a curve. So intersection of a line and curve, You can solve a line when two lines, when a line and a curve intersect, then you can solve them by using uh, simultaneous equation, right? Because and the point of intersection gives you uh, tells you the nature of the root. So instead of doing all these things, what you have to do, you have to first apply the rule that you follow in case of simultaneous equation. You change into a single variable, and then you apply these condition. Discriminant is greater than 0 or lesser than 0, or or equals to 0 to find the value of unknowns. Like for example, you have to solve a line and a curve. Number of points of intersection will depend on the value of b square minus 4ac. So if b square minus 4ac, it can be greater than 0. If this value is greater than 0, then what about the nature of roots? You will get two real and distinct root. And now you are solving a line and a curve. This is intersection of line and a curve. And it means that your line will intersect the curve at two distinct points. Similarly, if value of the discriminant is less than 0, you will get the value of discriminant. When you solve simultaneously line and curve, then you get an equation with a single variable. So when you solve the discriminant after solving the curve and line into simultaneously, then you get a line, a curve, a single equation, quadratic equation with one variable only. So, and then you find its discriminant, and if the value of discriminant is lesser than 0, it means the roots are non-real. Or no points of intersection. Means the line does not intersect the curve. And if it is equal to 0, then it means that you get real and equal roots. You will get two real and equal roots. And it means that there will be only, because the roots are equal, so there will be only one point of intersection. And when the line intersect the curve at one point, then it is called, line is called tangent to the curve. Line is a tangent. So this is basically condition for line to be tangent to the curve. Or you can show this like this, for greater than 0, the shape of intersection will be like this. They will meet at 2 points, or for less than 0, it will be like this. There will be no intersection. And when the b square minus 4ac is 0, diagram will be of this type. Line will be tangent to the curve. So this is basically a brief summary of the topic. Okay, how can you solve a line and a curve, and then can use this discriminant to find the value of the missing constant. Like for example, now we do related questions in which we apply this concept. For example, question is, We solve question from book. For example, it is given that find the set of values find the set of values of K for which the line y is equals to K minus X cuts the curve y is equals to x square minus 7x plus 4 in two distinct points. Now you read this question carefully. You have to find the set of values they are missing of K, and for which the line you are given a line that cuts the curve or intersect the curve. Then you are given an equation of the curve y equals to x squared minus 7x plus 4, and it is written that the line and the curve intersect at two distinct points. Now you have to note down the steps. First, you will solve this line and curve simultaneously. Now you can substitute the value of this line y equals to K minus X in the second equation, which represents the equation of a curve. So you will here write K minus X is equals to x square minus 7x plus 4. Now you will take all these on the other side. So you have to transform into a single variable by eliminating the variable y. Now we solve the like terms. Minus 7 plus 1 is minus 6x plus 4 minus k is 0. So this is your first step. You solve these two equations simultaneously and change into a single variable. And now you can easily identify the value of A, B, and C. A is 1, B is minus 6, and C is this plus 4 and minus K. This is C. And secondly, now you need to note down the value of the condition, which is two distinct points. Two distinct point means what is condition for finding for two distinct points? The condition is the discriminant is greater than 0, which is b square minus 4ac is greater than 0. So you can substitute value b is minus 6, a is 1, and c is 4 minus k. So when you expand it, minus 16 plus 4k is greater than 0. So 36 minus 16 is 20 plus 4k is greater than 0. Now you can take this 20 on the other side. It will be negative and k is greater than minus 5. So this is how you can apply, find the value of k. So you can get various conditions in different questions. There will be variation like this. You may get, instead of two distinct point, it may be written as the curve does not meet the line, or the line does not meet the curve, or you may get the line is a tangent to the curve. So we apply, the first part is same, like first you solve them simultaneously and there will be a variation in condition. Sometimes you will write here b square minus 4ac is greater than 0, or sometimes you will write here b square minus 4ac is less than 0, or b square minus 4ac is equals to 0. Now we'll do more questions in next video from past papers.